All right, so today we're working on quadratic application problems. And so look at the first example in your notes, and it says, find two positive real numbers that have a sum of 64 and a maximum product. So we'll just start with the two positive real numbers that have a sum. So we'll say that x plus y equals 64. And then they also have a maximum product, so we can say P equals X times Y. Now right here you have three variables, so we need to create a quadratic here. So if I just take this linear, we can say that Y equals 64 minus X. Take that 64 minus X and we'll plug it in right there. So when I do that, I get X times 64 minus X. So right there, I just created a quadratic. Okay, you'll see keywords like maximum, okay, or anytime you're dealing with a rectangle or area, something like that of a rectangle. Those are some things that maximum definitely tells you that you're working with a polynomial. Right here, we created the quadratic, so you can see that it'll be a parabola. Okay, now, so what you want to do here, also because it says maximum, this is talking about the vertex. So what you want to do is just plug this quadratic into your calculator. So let's see if you can see this. There you go. So let's go here. And I'm going to plug that X and then 64 minus X. So I can see that my zeros are 0 and 64. So go to the window and let's make sure our domain will cover those zeros. So if I go negative 10 to 70, something like that. Now what you want to do is hit zoom 0. So what I'm doing is I'm plugging in a domain that I want, and then I'm going to hit zoom 0, which is zoom fit, and that will keep that domain, but it will make the graph look pretty. So it'll adjust the range, and there's the 0 and there's the 64. We're working with the vertex right there. So let's hit second trace, and we'll go maximum. Go a little bit left of that maximum, press enter. Then go a little bit right of that maximum, press enter, and then go back 2 a little bit. So there's our vertex is 32, 1024. So 1024, that is the maximum product. That's not what we're trying to find. We're trying to find the two real numbers that create that maximum product. So we know X is 32. Then we can plug that in up here, and we get 32 plus Y equals 64. So we know that Y is also 32. So you got to pay attention to what the problem is asking. It's asking for the two positive real numbers that have a sum of 64 and give you a maximum product. So those two numbers would be 32 and 32. Okay, look at the next one here. You have a 4x6 rug, which covers half of the floor area of a room and leaves a uniform strip of bare floor around the edges. Okay, so we've got this little rug here, 4x6, which is an area of 24 square feet. And then the room is going to be a uniform width. By uniform, they mean that this distance here is X. Same with this distance over here. Same with this distance here and up here. Everything's X all the way around. Okay, So we're trying to find the dimensions of the room. So this long side here would be 6 plus 2x. 6 plus 2x. The short side here would be 4 plus 2x. I've got x here and x here. 4 plus 2x. So that area, let's see, 6 plus 2x times 4 plus 2x. Let's see, the area of the rug, which was 24, remember the rug was 24, is half of the area of the room. So the area of the room is 48. So now I can set this equal to 0. Minus 48 equals 0. So that's what we'll plug in to find x. So let's do that real quick. Make sure you can see that. So 6 plus 2x. Four plus 2x. And then minus 48 right there. So I'm just going to hit zoom 6 and just go back to that standard window, negative 10 to 10, see what that does for me. Okay. Now you have two zeros here. Notice this problem didn't say anything about maximum or minimum, so we're not using the vertex. This time we're using the zeros. And you have two zeros here. You're not going to have a negative width right here. So that negative, what is that? Negative 6. That doesn't matter. It's the positive 1 that we're going to use. So x equals 1. We can check that if you want. We can hit zoom trace 0. You could go to your table if you want. Whatever you want. But left bound there. Right bound, and my 0 is 1. Again, you can see that on the table as well. Right there, 1, 0. Okay, so x equals 1. And so what we're going to do is we'll just plug a 1 back in. So we get 6 plus 2x, or 6 plus 2 times 1, and 4 plus 2x. So there's our dimensions of the room. So this is 6 foot by 8 foot. Okay. Now, one last problem here that I want to show you. A rancher has 200 feet of fencing to enclose. So we have two rectangles, two identical adjacent rectangular pieces of land. So we'll call this x, this y, and then this x all the way around like that. So we have 200 feet of fencing, so we can say 4x plus 2y is 200. Okay? And then let's see here. What is the maximum area? So we're also dealing with area, which would be, let's see here, 2x, right? One side right here is 2x times y. So this is another one where we have to create the quadratic. We have three variables right here. So I'm going to take that 4x plus 2y equals 200 and just solve for y. let's see here. There you go. If I divide everything by 2, I get 2x plus y equals 100. That's an easy way to do it. So now we're looking at 100 minus 2x. And then let's just plug that in for y right there. Okay, let's see if I can come over here. So the area is 2x times 100 minus 2x. So grab your calculator. Again, we're working with maximum. So that's talking about the vertex. So let's see here. Can you see that? Go to y equals. Clear that out. We're looking at 2x times parentheses 100 minus 2x. Let's see, I've got a 0 at 0 and I've got a 0 at 50. So I'm going to go to my window and go from -10 to 60. That way we can see both of the zeros. Again, I'm going to hit zoom fit or zoom 0. There's your beautiful graph. And we need the maximum, the vertex. So second trace, maximum. We'll go left, press enter. We'll go right, press enter, and then back 2. So I have a maximum at 25, 2500. If you go back to your formula here, it says A equals, so A is the Y value of the vertex, and that's the area that we're looking for, the maximum area. So A max is 2500. And I'm out of room, but I'm going to put it right here for you. A max is 2,500 square feet. There you go. So there's 3 problems. Feel free to go back. I'll put this on Google Classroom so you can watch these again, pause it, do whatever you need, and work through your homework. There's some good problems in there. I think I give you a good window for each problem to use. And let me know if you have any questions. I hope you have a good weekend, and I'll see you on Monday. Thanks.